And I'm going to stop screen share for just a minute and then we will continue. I just need to get some stuff set up, which will take me a minute or two. And I'm letting people into the class, and we're going to continue with chapter 8, which is the documentation chapter. And I will share it in just a second. A file that I need, it's not loading for the lecture, my PowerPoint. So I'm just trying to go in and figure out uh, why that's happening. Just bear with me. My stuff is not, it's giving me problems downloading from my OneDrive. Oh. All right, I finally got it working and I'll share my screen now. All right, so we are in chapter 8, and this deals with documenting system and processes. So these slides that I'm now using, they are available to you. And if you go into your Wiley course resources, if you log in, I'm going to click on that. And then under course resources for chapter 8, you see these PowerPoint slides. Okay, so this is available to you. I will not be providing it separately, and students then continuously ask me, where am I getting this? It's right here. So it's in Wiley Course Resources, Chapter 8, PowerPoint. Anything else that I'm adding to it, I typically will upload it onto the home page. Accounting 341 on the content section. But for right now, what we're going to be covering, and this is a continuation of what we did in the previous class, but in the last class, we went through how you would actually create a flowchart using the draw.io. And now we're going to be going through some of the theoretical stuff behind it. So next several weeks, I'm going to focus a lot more on the theoretical stuff, which is directly from the book. So, uh, all right, so we're going to start off with the first one is what are the main goals of documenting systems and processes? And so documentation is a formal record that describes a system or process. And what we mean by system or process, I will explain in a little bit of detail in a few minutes. But it's something that will describe a system or process. And probably the best way to think of a system, or in the case of an accounting system, right now, just think of it as a computer program. So when you're thinking about a computer system, you can document that, or a process, any function that you're performing, any task that you may be performing, how would you be going about doing it? That would be the process. So, for example, if you are receiving inventory, what would be the process? What are the steps that need to be followed? So you would be documenting that, how using one of these documentation techniques. So companies use documentation for several reasons, and some of the basic ones are to comply with laws and regulations, to troubleshoot and maintain consistency across employees' work and how employees are trained, capturing usable information for process improvement, and documenting and evaluating internal control activities. So for us, documenting and evaluating internal control activities will be a big part of how you would use it in accounting, auditing, etc. Any questions, you can just send to me. Otherwise, I'm gonna keep moving on. So within this category of documentation, we have something which is called systems and program documentation. So system documentation would be an overview of the computer system with details of system design and architecture. So system is much broader in scope, whereas program documentation is detailed description of the system's programming, logic, and source code. So this is the first category that we're going to be discussing. In addition, you normally maintain operator documentation and user documentation. So operator documentation is necessary for the technical operator to execute and support the system. And then user documentation is for the final user, instructs the system user, or this would be the end user, on how to interact with the system. Now, within these four categories: system documentation, program documentation, operator documentation, and user documentation, these are we calling classical concepts. In the past, and I'm now going back from 1960s, 1970s till recently, the way you have used computers has changed significantly. What this is describing is something that was the prevalent way of doing things about 60, 70 years ago. We're still utilizing it, but some of the things, such as this operating documentation, are no longer as important. User documentation is important. In the past, you would have someone between the user and the program that you're using, doing quite a few things. Nowadays, probably a better way of looking at operator documentation would be someone who is in tech support and the type of information they are likely to provide. So for a legacy system, for a classic system, this makes sense. These four types of documentation: system, program, operator, and user. So, but I feel at this particular time, this plays less of a role. And again, let's go into all of these in a little bit more detail. So system documentation is the overview of the computer system at the most granular level. And let's talk about the different things that goes into system documentation and then who is responsible for these things. Who is it for? The developer primarily. Who's going to be using system documentation? The developer. And why would you, as an accountant, need to understand it? Well, auditors need to understand the architecture and design of the system they're auditing. So what is this system doing? This is capturing information. Generally, we are now talking about financial information. So primary user would be the software developer, but auditors should understand how that software is functioning. So that's basically the reason, the importance for system documentation from an accountant's perspective. And things that will capture are system architecture, technical design, user interface design, inputs and outputs, high-level processing logic, how the system interact with other systems. So if you're talking about an accounting system, how it interacts, for example, with the sales system, marketing system. So how various systems will interact with each other. And the forms of documentation. This is what we briefly discussed in the last class. You have typically three main forms: narrative descriptions, flowcharts, and then data flow diagrams. And we have something called enterprise relationship diagrams. They sort of, it's something which is a little bit more specific, which when we're dealing with databases, and we haven't done these, I will probably see if we can do an example or two for the ERDs. So at the next level, again, we are going through the four levels: top level, system documentation, then program documentation, then we'll discuss operator and user. So after system documentation, we have program documentation. So in program documentation, we are going one step further, one step down. It's referred to the software or technical documentation, describes the detailed analysis of the program and its logic. So this is helpful if the programmer is unfamiliar with the system and must troubleshoot it or figure things out in an emergency. So program documentation is a little bit more technical in scope, and its primary user is programmers. So a computer programmer is likely to use this. So as an accountant or an auditor, you are less likely to get involved with this. You are likely to be looking at things at a higher level, at the system level. You'll need to understand how that works. But this is translated into program documentation. So something that programmers would be using to program the system and then make changes to it, maintain the system. So this will contain programming logic, more details about how data is input and what type of information is output, and program source code. Source code is the actual code, actual program that is being written. Again, you would document it using the same techniques we talked about earlier, flowcharts, um, flowcharts and entity relationship diagrams. And in addition, whatever the program is, the code can be written out or listed, source code listing, and then record layout, which would be the database related information. Operator documentation is next level down and is often referred to as run manual. It provides information necessary to execute the program and make it work. Now, this thing does not have as much of a role nowadays. In the past, it did. So we'll go through it, but it's not as critical for modern systems. So it's for the use of computer operator. What are the required equipment and supplies, execution commands, error messages, what they mean. Really, the best way to think of this portion nowadays is somebody who would be supporting the user, tech support. In the past, and again, if I go back to 70s, 1970s, the end user would not really directly be interacting with the computer. You would have someone in between, which would be the operator. They would be doing quite a few things. And nowadays, I would say yes, protocols for backup and data recovery, they would be doing that. So this is a role which is not as critical nowadays as it was in older or legacy systems. Their work would normally be narrative description, a written guideline in paragraph format, explaining them what they need to do under various situations. And flowcharts always come in handy to explain the flow of the information within a system. And finally, user documentation. This is what the end user is going to be using. And so auditors would definitely, accountants would be looking at this to understand how employees are actually using the system. And basically, it contains information like a tutorial or some sort of guidance. How would you use the system? What functionalities are available? Tips, etc. And nowadays, again, I'm differentiating it from the past. Nowadays, often at times, user documentation is incorporated into your software design. Not always, but often. And simple example would be that if somebody has to input something, we may have like a small icon showing them help for that input field. Well, that's just an example of user documentation. And then, of course, it can go into it in more detail. So you're using, for example, Brightspace. If you want to look up some functionality of Brightspace, what would you do? If you cannot figure it out just by looking at the interface, well, then there is basically online help which is available. And I'm talking written documentation that you can go to and look up information. So it will contain common errors, how to resolve it, how to input data, etc. And this is typically done as narrative description, possibly as flowcharts. But most of the time you would do it as a narrative description. So differentiating between the documentation techniques. So why would you be documenting? We talked about this right at the beginning of the class. We're gonna sort of repeat it right now. So why are we documenting a business? And it's basically for multiple reasons. An important one is for knowledge transfer. So once somebody knows how to do something, and I'm going to give you a very simple example of what you may want to document. Imagine you have a small business and you have a process to close your business at the end of the day. So, what do you do at the end of the day when all your customers are gone? I assume it's a retail business. Okay. What will you do at the end of the day? Or let me go more specific. Imagine you have a retail jewelry store. Okay. So you sell gold and diamonds and all sorts of stuff like that. What would you do at the end of the day when you are leaving? So, a couple of things might be that, yeah, you're going to turn on the alarm. Okay. Another thing might be that all the display items might have to be taken out of the display and uh, recorded or put into a safe because every single thing is high value item. So you're going to be taking it out. You're most likely not going to just leave it in the display, but there might be some items which are low value jewelry items that you can just leave in the display and you don't want to remove them. Well, what is the entire process that should be followed at the end of the day when you're about to close the store? So that can be documented. There's a reason you would want to document that. One is efficient knowledge transfer. So, how do you close your jewelry store at the end of the day? So, you might have a store manager, and that person leaves, and somebody else now needs to be able to do this. Somebody will have a written guidelines explaining to them how it's done. So, as a source of training future employees, efficient knowledge transfer. So it's going from one human being to another. How you're doing that? By writing it down, by standardizing the process. So, like I was just giving you a description. Okay, I'm going to turn on the alarm, then open up the safe. Well, we should be doing things in a very specific order. So you probably want to lock the door and you don't want somebody, your staff members, for example, that the doors are unlocked and you start taking things out of display and opening the safe. So maybe the first step is make sure that the front door is locked. Maybe even make sure that the shutter is down. Then you are going to go in and maybe take items out of the display. Then once they're out of the display, you are going to log them. Then once they are logged, then they're being taken into the safe, putting into the process. Maybe two people need to observe. So whatever that process is, you're standardizing it, making it so that everybody follows the same procedure. And that's what we mean. So when you're documenting, that helps you standardize your practice, that people are not doing things different ways. Also, when you're writing things down, that can help you figure out, well, maybe there's a better way to do something. And that's process improvement. And of course, this documentation, knowing exactly what the closing procedure is, for example, can be effective from an audit perspective. Any questions so far before I move on? And again, material related questions. If you have general questions, I'll answer them towards the end of the class, but material related questions. All right. So documentation techniques. Document is used to create, capture, evaluate, and audit processes in the accounting information systems. So the appropriate form of documentation depends on what you're trying to document, what's going to make sense, and the type will be used documenting the overall business, documenting processes and systems, documenting data. So these are three items, and we'll discuss these. Documenting the business involves capturing the people who work there and the state of operations and internal controls. So one example might be an organizational chart. So this is basically a diagram that can illustrate employees in a company. So, and I'm gonna get out of this for a second. If it will let me, yeah. And I'm gonna, let me see if I can use Gemini. Show me a sample organizational chart. And let me see again what I get off of it. If not, I'll try to Google and see if there's a better example. That's not what I wanted. Let me, I really don't want to use this particular resource, but uh, and let me see if I can open this up. All right, so it just gives you sort of an idea. It's not all that great because I'm not using the right software, but it just gives you an idea of an organizational chart. So usually the company's president or CEO is at the top, and then you may have various departments like a accounting department, marketing, finance, so on and so forth, human resource. You would have that, and then within that, um, each department head who is reporting to that, who's there. And this could be in the form of the actual employee names or their functions, what jobs they're performing. So, again, just a simple way of documenting. I'm going to close out of this. Simple way of documenting uh, documenting the organizational structure. Okay. Now, sometimes people outside the business, like auditors, need to understand what is happening, and they will be using a checklist or a questionnaire to gather information about specific procedures and internal controls. So, checklist is, and questionnaires, I don't think I need to give you an example. Um, it's fairly simple, straightforward, almost like a to-do list that you might be creating, or questions that you may need to ask to get a better understanding of the overall business and its process. So our organization structure, we did have an example in here. You can take a look at it, and we're going to move on. Processes and systems can be documented with narrative description. Narrative description is nothing more than saying in the form of a essay or some sort of a outline narrative. You're writing paragraphs. Or if it's more complex, depending on what's happening, flowcharts. So what are, these are relatively easy to both of them nowadays, relatively easy to create, and typically, at least in the past, again, not necessarily now, it was easier to update a paragraph narrative. And the reason I'm saying in the past is if you have to actually draw a complex flowchart, it would not be as easy to update. Nowadays, with the use of the type of software we have available and artificial intelligence, uh, there isn't a big advantage to narrative. There's probably still a little bit of an easier for you to just go in and edit like a Word file, but not a significant advantage. And flowcharts may be used um, only for critical purposes, systems, and less critical items can have narrative. I want you to keep one of the things in mind, especially with accounting information system textbooks. A lot of the stuff that's written and given to you is based on stuff that used to be true 10, 20, 30, 50 years ago. And, they don't always keep up with it. And again, the way I'm looking at it, it's fairly easy. If you've got a narrative nowadays, from that, generating a flowchart is fairly simple using AI, and you don't need to really sit down and program it. So this is not when you're doing questions for exam purposes or homework purposes, I want you to stick with the answers which are in the book. So whatever they're telling you this is easier to update, I want you to stick with it. But I also want you to understand on a practical level that these things were true, but they haven't been true for quite some time. Even in mid 90s, around 1995, this really was not true. At that time, we had fairly good flow charting software, and I could easily update. I could just as easily update a flow chart as I could a narrative. So this logic to me is something which is uh, probably from 1980s and before. It's that long time ago. So even from, like I said, mid 90s onwards, it was fairly easy to be able to create flowcharts and update them. But when it comes to answering questions, when I give you homework assignments, quizzes, exams, uh, despite what I am saying now, your official answer should be based on what is in the textbook, because that's how you're going to get graded. And this stuff will carry over onto the CPA portion of the exams as well. So, whatever the book is saying, authors of CPA exam questions rely on this type of material as well. And so even though I'm telling you from a practical point of view, no, it doesn't really make much of a difference. But when you're answering questions, make sure you stick with the formal answers which are coming from the textbook, not what I am saying. So narrative is basically a written description of the systems and processes, and a narrative may be accompanied by visual depictions such as a flow chart. I think we've gone through this. I'm going to move on. Flow charts. We already did one in the last class, and basically, I think I'm going to move on. Okay, so next one, business process model and notation, BPMN. It's a documentation method that depicts the step of a business from start to finish. So it's like a process flow chart. It is visual and can be easier sometimes to understand than a narrative description. So the two differ in the shapes and technical layouts they use, but they basically serve the same purpose, could be used interchangeably based on the preference of the creator or business stakeholders. So, documenting data, while system flowcharts capture the flow of information, sometimes you need more technical documentation. And in this case, you're keeping track of movement of data within a system and how the data is actually stored in its database. And we'll see some examples in a few minutes. So, to this end, how data is stored in the database, we have this thing called data flow diagram, and then we have entity relationship diagrams that we're going to talk about next. A data flow diagram, graphical representation of the flow of data in an information system. So it will show functionality limits, documents a business process, easier to use than a text description. And let me actually get to one of these, and then let me bring something up so it's a little bit easier for you to understand. Otherwise, it becomes, and we do not have an example of data flow here. I'll have to check in the book, or I will get something on the web. So let's leave this alone for just a minute. But its purpose is simply to show the flow of data within an information system. So almost like a flowchart, but much more specific in its objective. This is something different, but again, related to the concept of data. This is an entity relationship diagram. And this is a graphical illustration of all tables and their relations in a database. So we did this when we were doing Postgres, that we had multiple tables. And when you had multiple tables, they would be related. So this works more for SQL or Postgres. Something like this could work with something like MongoDB, but typically this is not how I would be modeling it. So the relational databases like Postgres, that's the one where you would be more likely to use this. And it illustrates tables. So this, each one, what you're seeing in here is a table, and how the tables are related to each other. And typically, this is the primary key, foreign key constraint, how the tables are related to each other. So ERDs would do that. This is a much more technical documentation. So when we are talking about how you document data, I'm going back a bit. We are talking about two separate things. System flowcharts will capture the flow of information through a system, but sometimes you need something a little bit more detailed, a little bit more technical. That's when you're going to get into these two, data flow and entity. So when you're going a little bit further down the technical ladder, going further down. So in this case, developers would create documentation that captures both the movement of data within a system and how the data is stored in database. So movement within the system is this thing, data flow diagram of how the data flows through the system. And entity relation diagram, basically how the data is being stored and how the tables are related. What are the fields in each table and how those fields relate to other fields in other tables. All right. So entity relationship diagram. So continuation of this one. From simplest complexity, simplest model introduces more detail, most complex. So we're going from conceptual ERD to logical ERD to physical ERD. You don't need to worry too much about each of these, but we're going to go through just examples so you are able to see it. I should have an example. Oh, let me get this from the. I need to get the examples. I thought I had them in here because I had modified these slides, but I was having trouble uploading my PowerPoint or downloading my PowerPoint today. So this is not my latest file, which has the updated diagrams. So I need to get you those separately. So we'll go back into it. Let me just finish up what I've got in here, and then we will go and take a look at these. This we need at a practical level anyway, when we are going to actually do the documentation. Okay. So we did this already a little bit, but this is sort of a typical example of a flow chart, and these symbols have specific meaning, and you should be familiar with the meanings for the basic flowchart symbols. So that's what we're going to talk about next. So flowchart shape. So the starting point and ending is a circle. So these are terminator shapes, start and end. So if you look again at this one, you're starting, it's a circle. And when you're ending, it is also a circle. So whatever the entire process is, start and end, you're documenting, you will typically have circles at the beginning and at the end. Next, a process. So the process shape represents an event or a step within the flow. A flowchart could be as detailed as just having a process shape for every step of baking cookies, etc., or at a broader level. So a process shape always has a single line entering it and can have multiple lines exiting it, because a process could be split into two or more parts. And so this is an example of a process. So a single line comes in, here only a single one is going out, but it is possible, depending on what's happening, that multiple lines could be going in and out. Next, we have this diamond shape and rectangle, and flow lines are indicated simply with an arrow at the end. Okay, next, diamond shape. This represents a decision, and it could be a yes, no, or true, false, something where something needs to be answered, and then based on that, it would split. So when the flowchart reaches a decision, it splits into two branches, one for yes, one for no, one for true, one for false, etc. So going back into our example, customer orders, and then next is decision. Does the customer want coffee? Yes. Doesn't want coffee? No. Doesn't want coffee? Okay, that's the end of the order, and you give the order to the customer. Yes, then get coffee and finish order and give to the customer. Very simple flow chart. So here we are looking at diamond or decision. Sometimes two or more pathways or connections are going to merge into a single one, and you use the triangle system, triangle to merge process flows. So just like the start and termination, you also have a connector symbol, which is a circle. Connector is used when things don't fit on one page. So imagine this is going to go on and on and on. So you might have a connector here saying A, the letter A. And then you go to the next page, and over here would be the start of A, or A is connecting to B, something like that. So when it won't fit on one page, then you will be using a connector to connect two or more pages together. So connector, when it's not, connectors are always filled with a letter starting with the letter A. A connector on the first page appears at the end of the flow chart of that page, and the connector on the next page appears at the beginning. The letters inside the two related connectors in the same. So essentially, you end at A on the first page and begin again at A on the next page. So just a connector, something that's used commonly. Some of the other items that are typically used in a flowchart. So a document is represented by this particular shape. Input, output, data is being entered, or data is coming out in one form or another as a parallelogram. This symbol represents storing of data. Data is going into the database. Manual input. So somebody's typing something into the system, for example. Some sort of a manual operation, not something automated through the computer, but something being done in a manual way, non-automated way, which is part of the process. That trapezoid symbol is used for that. So it's just giving you a very basic idea of putting this together, a process flowchart example. Start, and you're describing the steps coming in here. Now a decision needs to be made, yes or no. With yes, you do this, and this is the end. No, you go through this, and this would be the end. Swim lanes, and I think we used these in the last class when we were doing the chart. So flow charts might have swim lanes, These are areas within a flowchart that delineate the responsibility for all activities in a business process. So, with swim lanes, you provide clarity and accountability by placing the activity within the swim lane for a particular individual or group. So it just makes it a little bit easier. You could have a regular flowchart, or you can have a flowchart with swim lanes. With swim lanes, it makes it just a little bit easier to see who is responsible for what function. And this would be an example of swim lane. So again, you have a flowchart, and within this particular flowchart, you have various departments, various responsibilities. So it's just telling you this is department 1, department 2, so on and so forth. And then from this department, it may go back this way. So this is just like a regular flowchart with the addition of responsibilities indicated by department, individual, whoever is actually responsible for doing that particular function. Makes it a little bit easier to understand what's going on. That's all. Okay, so all right, so within the data flow diagram, again, we have the same thing with these symbols. I'm not going to spend too much time with data flow diagrams. Just going to stick with it. Uh, it's not as critical for us. This one, the standard flow chart with a swim lane, this is something that I would like you to know well. This is what you're going to see most of the time. The data flow diagrams are a little bit more specialized if you're working in on a technical level, not as an accountant auditor, then you may be looking at it. So just a very basic understanding of data flow diagrams would be sufficient. And I'm going to just move to where we actually have a data flow diagram. Okay. So it's basically at a, at a broad level, customer, orders getting entered, and then orders. So within these, each component that you're seeing in there, this is created using 4 shapes. A rectangle in data flow diagram might look the same as a rectangle in flowchart, but it represents something different. So external entity, the external entity shape represents an input or output of data flow diagram. These entities are called external because they are either entering the system from an external place or exported out of the system to an external place. External entity shapes are often the beginning and ending shapes of a data flow diagram and can be called terminators. So this is similar to when we had circles, but this is different, obviously. In contrast to a flowchart terminator, an external entity cannot just say start or end. It must be a real activity that is providing or receiving data. So go back and now look at this. So this is what we are calling a real entity. So the customer is providing or receiving data. That's what this shape is telling you. And of course, in this particular case, the customer is not receiving data, it's providing data. What data? Data about the order. And obviously data flow line, it's easy to understand. So we got the external entity share. So in this diagram, you see the customer is providing some data. Next, process. The process shape represents an activity that transforms or changes. So we had process before also. This was the process rectangle. I'm talking about flowchart. Similar. Uh, so going back in here, the process represents an activity that transforms or changes data. And the decimal number, such as 1.0, identifies the process for quick reference. So processes are always expressed as a singular verb and a singular noun, such as verify, order, apply, payment, so on and so forth. A process shape must be connected to at least one external entity. So this is process, and we're going to go and look at what's happening here. So customer is providing the order data, and in this step, we are entering order. So this is the actual what we will be calling process, receiving data from the customer and then taking action on it. Enter order. Connected lines, we all know. And let's go back up. Data store. The data store shape represents data repository, such as a database, data warehouse, etc. Data store retains data for later use. So a data store can be the beginning or ending of a data flow diagram, a D and a numeric, such as D1. They're used to identify data store for quick reference. Name of the data store describes what the store is storing, inventory or order. So let's go. So in here, the order was entered and it is now getting stored. So the orders are getting stored in some sort of a data store. We know it's a data store because we're using D and then the number 1 to identify this particular data store. There are 3 levels to a data flow diagram. Each new layer adds more complexity to the data flow diagram. So we started off at the top level. I'm going back. Okay. So data flow diagram is a graphical representation of the flow of data in an information system. So you just saw an example of customer order. So what are the advantages? It shows system functionality and limits, documents a business process from the perspective of related data, easier to use than a text description, offers easier to understand system diagram for users to comprehend data flow. So this is all focused on data flow, helps new people understand the system and helps the auditor use the particular system. So this is the data flow diagram. And this is what we just went through. So now this one is at 3 different levels. Each layer adds more complexity to the data flow. So to find the inefficiencies in data flow, an IT professional may depend upon the greatest level of detail that is offered, while a business end user may prefer a high level overview of data flow diagram to understand the big picture of data flow. Again, this is much more of a technical documentation, and unless you are involved in the technicalities, you're less likely to use this. Like I said, between this and the flowcharts are what would be important for you to understand and be able to go through it. So this, again, I'm just covering it for the sake of completeness, but not something that I will be emphasizing. We're not going to do any hands-on questions with respect to data flow diagrams and even ERDs. I don't think I'm going to get into those. So a level 0 refers to a context that is a summary at the highest level. So level 0, data flow diagram at a high level or at a broad level. Level 1 gives a few more details, decomposes it, and you can see an example of that in here. Level 2 will go even in more detail. And you just have an example of this. And when you're going into level 2, you're getting into these decimal numbers. So this is usually the most detailed. Process numbers include decimal places to indicate sub-processes of level 1 process. So only thing, just sort of keep in mind, if I gave you just this and I said, is this level 1 or level 0 or level 2 DFT, you'll know it's level 2 because of the decimal. On level 1, we did not have any decimal values. We have just 2.0, not 2.1, 2.2. So it's at a broader level than level 2, no decimal values. And just at the top level without giving much details. And that's basically it from this chapter. So I'm gonna close out of this. Only thing we are gonna do from this one, or I will be giving you some sort of a flowchart example. And yeah, we are almost out of time today, so I'm not gonna do that today. But I'm bringing up my notes from the last class. Okay. So this is from the October 22nd class. We did question A9 from the Wiley book. We created a process flow chart for draw IO, and I have information in there, including we told the AI to use swim lanes, and I specified one for customer, other for ATM machine, and then we had, I forgot which one we used, probably Gemini, I'm not sure what we used last class, or Chat GPT, but one of these AI tools you can use to generate this. And one of the good things is that Draw.io is able to read files which are in XML format. And when you're using these AI tools, you just have to tell it to generate a draw.io file as XML. So whatever your description is going to be, you tell it whatever you want it to chart, and then towards the end specify that you wanted to generate a draw.io file as XML, and not always it can make a mistake, but most of the time it will generate it for you. And you may have to do some minor editing. So from this chapter, I will be giving you the theoretical stuff that we've just done, some multiple choice question um, on it, and I may give you one um, assignment where you would actually be drawing something using Draw.io and or some sort of an AI tool along with Draw.io. So that's it for today, and we'll continue on Wednesday. And anything about exam submissions and this and that, I know, and I will tell you what needs to be done where. So right now, you don't need to worry about anything. I will tell you whatever the next stage is as far as the exam is concerned. Any questions? Let me know. Otherwise, I'll see you next week.